Hello viewers, welcome today. This is a video again on an update on Multicast DNS. Previously in a YouTube video focused mainly on poisoning IP addresses and creating what we call collision names. But today I'm going to look at basically creating some spoofing services like shares and some fake other services like PTR records and TXT records. So let's get to it. Let's keep this video as short as possible. So let's get into network neighborhood in Macintosh first, and this is the network properties. As you can see, we have our house backup, we have a computer over here, and we have another computer over here. Okay, not many as you can see. If we go to the Ubuntu machine, okay, we go to admin, we go to other locations, we see a file sharing device over here, we see another computer over here, and we see a Windows network. Now all this basically works through Bonjour or Avahi. Okay, so as you can see, this computer is discovered through the Multicast DNS system using the PTR SMB protocol. Okay, so what does this all mean basically, and how can we spoof it? Okay, so if we get, let's close this. Here's another computer that came up here. Probably through NetBIOS, probably through the legacy protocol. It's a Windows PC. So what we're going to do now is I'm going to go to my Windows Server 2016, and I'm going to run this script over here that I basically created, and we're going to create an array of machines that exist but are point to the same share. Now this machine is an SMB share, and it can read and write. So let me execute this, and we'll get to it. Now before I get further, it's discovering now. Look at that, it's discovering. So it's doing its stuff right now as we speak. This PC, C drive, there's my share, and there's the stuff inside my share. Okay, it could be a virus, a Trojan, it could be whatever it is, a payload of some type. So basically that's my script basically poisoning the network. So now I'm going to go to a Macintosh, and I'm now going to go to my network, and boom, there it is. That's basically, now I can see a huge number of computers that wasn't previously there. You might be asking, well, how can it be? Okay, so basically what's happened here is basically when you discover this network, okay, this is a PTR record for SMB TCP.local. It asks basically, okay, where are these Samba shares? When it hits my script basically simply generates a random ID, okay, for a random string, as you can see on these on the screen over here, and it generates a huge array of machines. Now about 50 to 100 about them, probably about 50 I'd say anyway. You know, it's probably a maximum that probably can probably attain anyway. And basically it sends them out as a huge multicast stream. And then basically what happens is it basically collects it over here, as you can see, and they click on one of them, it says connecting. Let's see what happens over here. Should connect, theoretically speaking. Yep, connects to a share. You can see it's mounted over here, and you can see it says putty.zip. Okay, so they all do the same thing. Let's unmount it. Let's go to another one over here. They all go to the same share. Here's another one. Here's now putty.zip. So it's created, and there's two of them anyway. If we go to get info, you can actually see it's a Macintosh, where a network. Of course, not a Macintosh, it's a Windows server, but we were able to disguise it as a Macintosh machine. So U-Boot. So as you can see from here, we are able to create an array of machines that simply point to a single share. Now of course this is actually can be a phishing attack. It's a wonderful stunt. Now this doesn't just work on Macintosh, but we can also make it work on Ubuntu by going to the other locations. And this is Ubuntu, as you can see. So if we go to Ubuntu, for example, click on one of these ones, it asks for a password. Just type in whatever password you want, so PPPPP, and type in connect. Okay, click on share, and there it is, putty.zip. So that could be a virus payload. Let's go back to inject, and let's go to other locations. Let's go over here again. Let's type in 0000. Let's type in connect, and let's go to share, and there it is again, putty.zip. So you can see basically we are basically poisoned the shares, and as you can see basically have all this array of shares written over here. So not just on Macintosh but also on Linux as well, we're able to poison the network neighborhood with a lot of these well, they're not fake shares, but the shares basically simply point to a single share. So all this array of shares you can see here, they all point to a single share. So anyone can simply click on these and be taken to a single to a single endpoint. Now what would be the point of this attack? Well, you could simply phish somebody and lure them into downloading something from a share. You know, this will be probably an internal network attack, obviously. Wouldn't work externally because Multicast DNS only works internally. This is the reason why I don't use bonjour in office environments. You always block it at a switch level, and you turn them off at a client. You know, for starters, that's why I depend on DNS and DNS sec. But this illustrates how dangerous these things can actually be, because as you can see, you know, if you actually were able to rename these like Mac-03-Mac-04 and so on, someone could innocently click on one of these machines and be redirected somewhere else anyway. Just like when you get an email saying, you know, your PayPal has expired, click here to actually reset your password. So as you can see, these actually can simply lure people into fake machines that simply delivered into rogue share accounts. And as you can see, basically this creates a whole new level. Now to give you an illustration of what's happening in Wireshark, let's go to Wireshark over here. Let me just simply disconnect the network cable over here. So I'm going to disconnect, and these computers will disappear, the computer, and now I'm going to reconnect them, reconnect them, and now they appear. Now as you can see over here, you can see these PTRs over here. So let me just press the stop button over here. You can actually see that we have a PTR for SMB TCP.local, and we can actually see you have more SMB.TCP. So basically these are the SMB, and these are more SMB over here as well. And you can actually see a lot of these SMBs are being delivered, and we have more TXT records, and we can actually see more TXT and PTRs. So basically all of these, all of basically this what basically is if we go into here, you can see answers SMB TCP.local is a PTR record, case flash random SMB TCP.local. So you can see this one's a fake one. Okay, DNS services D. Okay, this is discovery services, which goes to SMB TCP.local. So this is to discover. And then basically this is a text record which is empty. This is an SRV record telling it to go to 445, target the local address. Then this is an IP address, and this is an IPv6 address. So all this has been properly forged. You can see how well forged this basically is. So all it has to basically do is look up basically PTR SMB TCP local, and they get these sort of responses. You can actually see how much response it generates, and this is the reason why you get all these computers showing up in front of your network neighborhood. And you can actually see how dangerous it can actually be. Now of course I wouldn't like to be clicking on one of these computers, because as you can see, if I were to click on one of these machines, and I click on one of these machines, and this was a ransomware file, my computer would be locked up and it'll be asking me for a ransom basically. So obviously this would be a very bad idea to be clicking on someone else's unauthenticated share, especially when you don't know who you're clicking to basically. So you know, obviously this is the reason why you need to be careful basically with Multicast DNS, as I said before. So I won't repeat again anyway any more further. So basically this is one of the attacks on Multicast DNS. Anyway, aside from that, I discovered a few other things as well with Multicast DNS as well in Windows. Windows now can actually resolve Multicast DNS without the use of bonjour. The latest Windows 10 multicast can actually resolve multicast DNS without actually the use of bonjour, which is from Apple. So I'm going to show you that one as well. Won't work on Server 2016 because it's old, but Server 2019 will do it. So aside from the SMB, let's go over here and let's quit this script over here. So I'm going to open this one over here, open with NodeJS, and I'm going to open this one over here, the IPv6 one. So both we're listing on dual stack, and what I'm going to do now is I'm gonna ping on my command prompt. Gotta get a command prompt over here, and I'm going to ping GGGGG. Now usually when I ping a multicast DNS domain, I usually ping with a .local, but in Windows you can actually ping without .local. Now let's see what happens when I ping this. Now theoretically in the older version of Windows it will return with saying cannot find name, but let's see what happens when I ping it right now. Okay, so notice basically as soon as I pinged it, it's saying it's pinging ggggg.local. So it's added the .local suffix for me. So obviously, as you can see here, basically I pinged without the .local suffix, but it actually added the .local suffix at the end, basically after I pinged it. So obviously we know that Windows can resolve the multicast DNS name without actually adding the .local suffix. So I pinged a single labeled name, but in reality it appended the .local suffix at the end as soon as I pinged it. So as you can see, basically, and we can actually do it in you can actually do it with Windows 20H2, which is the latest at this current moment, and you don't have to install iTunes. Just do a clean install, and you will know basically where to ping the .local computer name of your computer. Basically, for example, desktop-705x2, whatever it's called anyway, or this PC.local or whatever it is anyway. It should be able to ping anyway, because Windows now basically doesn't just discover bonjour, but can also resolve bonjour. They included an MDNS responder embedded in the operating system. The latest Windows 10s now basically can resolve it. Anyway, up to 64 characters you can ping. So if you ping beyond 64 characters, you'll get an error message saying cannot resolve name. So both Laminar and multicast DNS can only go up to 64 characters. So basically I found that out basically by tweaking the pings. So yes, now I'll show you something interesting. If you go to a share and you go to .30, here's my zip file. It comes with this message saying opening these files might be harmful to computer. If you go to here, for example, here, and you go to I go type in I type in .local here. Okay, .local. Okay, and I do the same thing. It says the same thing. Opening these files might be harmful to computer. Click cancel. However, if I do the same thing but I delete .local out of the way, guess what happens? This time it doesn't come up with the harmful with the computer. This time it simply goes up with an opening the dialog box, and you can actually run it without a problem anyway. So it skips the dialog box of the harmful to your computer. So obviously single labeled names are trusted. We can also verify this on your on the web server. We've got a web server running on the server 2.168. Let's go to 30 here, 30, and the password is here. Let's download this, for example, and save it and run this. See if it runs it. Should come up with a smart screen filter. No, it didn't. Okay, it's probably because it gets signed. Okay, hang on a sec. Let me try again. Download it. There we are. Okay, so this file came from another computer, and it might be blocked to help protect this computer. So it comes with the let me show it again quickly. It comes with this unblock checkbox. Now, if I do the same thing, doing .local/admin. Now this web server is local, so it doesn't matter if I'm doing the password part because it's only local anyway. Save. Let's go to properties here. Look over here, unblock. Still saying block to help protect this computer. So saying it's blocked still. Okay, now I'm gonna go to log out, and I'm gonna delete the .local here. Put a / to tell it's a web server. Go to admin, tab admin, and now I'm going to download this file. And now, guess what happens? That checkbox is gone. So as you can see here, just like the share, single label names and windows are trusted as intranet zones. So .local names and IP addresses are treated as internet, while single label names like computer names like computer1 or John PC are treated as intranet names or local internet names, local intranet names, sorry. So there is no message saying unblock over here. So as you can see, basically, these are things that basically I discovered here. Basically, you know, and Elementor does the same thing as well as discovered in Windows. Now, final thing before I finish up over here, before I finish, I'm just gonna go to my server 2016 over here and close both of these scripts. I discovered another thing over here in XAMPP, a program here called Pigeon. Now this is an XAMPP program, and I'm gonna run this program over here, and I'll show basically what happens here. And it generates all these names over here, as you can see. And this is a chatting program that depends on Bonjour as well, if you want to. This is part of the reason why, you know, Bonjour is probably another dangerous tool to run. And it looks like, I think it's probably crashed the program, I'd probably say. You can see the script here, it's generating a huge amount of requests to the program. And it looks like it's not able to take it. Let's see what happens, and let's see what happens anyway. But I think I'm gonna have to basically probably kill it and restart it again. The TTLs are set to 1 day, so it's poisoning the service up to 1 day. And there it goes again. Let's see what happens. Okay, I might have to close it here. So close the program. Okay, so there we are. So you can see basically it's generated all these values, and as you can see basically that's refreshing again basically. So it's created like a denial of service to the client. Now it's come up even more now. Okay, so now it's come up even more now. So all of these are services that simply don't exist, and I created all these services basically by modifying the txt record field in the Multicast DNS service field in JavaScript, in NodeJS anyway. Now if I go to Linux over here, to Linux, close that window, got a Pigeon here, and see what happens. Still launching an array. So you can see basically it's generating a huge amount of multicast traffic on the network, and it's basically generating a large amount of multicast traffic. So obviously Linux picked up only one, and as you can see it's picked up Alex, Winton, Person, this one, but it hasn't picked this one. It's only picked up basically on the an array. So obviously it's only worked for this machine over here. But as you can see, basically as you can see over here, it certainly crashed it anyway. We'll see what happens with this machine over here anyway, if it generates anything different anyway. Maybe if I close one program, maybe it generates another one. I think it's crashed it over here as well anyway. No, nothing over here. Okay. Okay. So basically, as you can see, these are probably some of the reasons why I wouldn't run Bonjour. It generates a whole heap of havoc. There it is. It's now running a bit more stable now. It's basically now it hasn't crashed now. It's running. So basically, you can click on one of these and you can talk to them basically. They all point to the same IP address basically. There's nothing basically incredible about it basically. They all point to the to the same IP address. But a few moments ago over here, this was actually working, and it was displaying a huge array anyway. And I'm guessing because it points to a single IP address and it's doing this, I'm guessing basically it's actually picked it up basically it's the same person all the way through anyway. Now it's frozen again anyway now. Anyway, I hope you enjoyed the video. It's obviously been interesting. It's been going for about 23 minutes, so I want to keep it as short as possible. As you can see, basically, these are reasons why you should stick away from Bonjour. I'm thinking of doing a video on SSDP. I figured a way how to do basically a something similar to what we did on SMB on Macintosh and Linux, but with doing web servers being discovered. SSDP basically is a way basically of discovering services. It's not Bonjour or Eliminar. It's a bit different. Basically, it works a bit differently using XML files and using a different multicast. Doesn't use link local. It's a bit more different. But anyway, I won't go into depth right now. But basically, it works the same way as Bonjour and it works the same way as Bonjour. Basically, in a very rough nutshell. You know, you discover like printers, file servers, NASs, you know, and you simply connect to them. You can play media service files. You know, you can view serial numbers, UIDs. So, you know, it works differently, but it does the same thing essentially. So I might be doing another video on SSDP, and I figured out basically how to create. It's not as spectacular as Macintosh and Linux through SMB through Network Neighborhood, but look, you will see basically how you can create fake SSDP services, and you can actually fish people out basically. It's something really incredible, but it teaches you why zero configuration devices should be avoided. And I think this video is meant to teach you in how it should be, you know, it should be taught us a lesson, on these things anyway. So as I repeat again, just be careful with these zero configuration devices, especially on office environments. Something that I always say, just to be careful anyway. If you go in Active Directory service, I recommend you use that basically over anything else anyway. Anyway, hope you enjoyed the video. I hope it was quite interesting to it, and I see you over there for SSDP, and I show some examples of it. Okay, have a nice one, and we'll see you over there. Okay, bye.